Alright, I gotta start this all over. Now I have a thermometer here that goes right up to here. At the end of this, I'm going to demonstrate how the temperature changes, because the first attempt I did this, I touched the wire and it like literally took forever for this to come back to its natural point of, temperature where it's naturally setting. Alright, so I have a digital ohm meter here, and the settings on resistance, and I have a knock sensor. This is a knock sensor from a Vortec V6 engine. It is designed to detect spark knock. I got the positive side going into the inner part of it, and then I have the negative attached to a plate that's in front of here, which then is attached to the knock sensor. And then the knock sensor has we got here going to the ohm, the voltage ohm, and common as ground. I don't have it up here in this setting because it won't give me a resistance because I have my sensor. Now the end of the thermometer, again I'll demonstrate, has a piece of aluminum attached to the sensor, just like how I have a piece of aluminum attached to my sensor here. So I have two sensors with attachments that go in to measure my net force. Now everybody's probably going, why do you have a thermometer hooked up to this? Because, well, they say kinetic energy is measured in calories, which is a temperature reading, not resistance. So we're going to see which one of these, this digital device or this digital device, happened when that up here, when this hits this. We're going to see which one's which. So kinetic energy, according to the way you do the calculations for energy, you should detect a phase shift in rise or defall, or up or down rise in temperature to be considered energy. If it's resistance, that means it's not energy, and then the definition of what we're teaching all our kids, well, I don't know. Sounds like what we learned in school was wrong. What I learned in school, at least. Well, alright, so what I'm going to do is I'm going to pull this back like that. This is an update, so I'm going to try to get footage. I had to flip the camera over. I'm going to try to get it with the sensors and the cradle hit at the same time. Let's see which measuring tool measures something. Let's see which one measures. Looks like I got a measurement here, but no measurement there. Let's try that again. And notice I knocked the thermometer out of the area, out of the spot. Put the thermometer back up in there. Put it back in the same spot. Try to do the exact same experiment. I'm using the calculator to hold the thermometer in place there. And if any of y'all know what calculator that is a badass calculator right there. You can do all of this stuff. I got crazy people sitting outside doing burnouts and donuts in the snow. Alright, here we go. Why is it going all blurry here? Alright. Alright, grab that. Pull up in the catapult. We're going to zoom back. You can see, well, the temperature changed on that already. Let's see which sensor gives me a reading. Things got to be in the way. Which sensor gives me a reading on which device when the action happens. See how I'm pulling back right there? And again, I got a reading on kinetic resistance. That is on the resistance with my knock sensor, and I still never got a calorie measured. So kinetic energy has just been debunked, and my educated guess was right. Thank you very much. That's an update, by the way, for the magnetic physics law in the second law, I believe. I was talking about putting a thermometer in there. There it is. And now, to prove that the thermometer works, I'm going to pull the thermometer out. This is the thermometer. I'm going to pull the aluminum off because aluminum is a really good semiconductor. There's my sensor for the thermometer, and as you see, as I'm holding the sensor, you can see the temperature is already rising. I have a frozen piece of meat over here, with this. Notice how the wire is completely separated from it. I'm going to take the sensor here. I'm going to put it on the meat. I'm going to flip the meat over and hold the sensor down like that. Let's see what the thermometer is going to do here. Oh, look at the temperature. Temperature is just coming down to 19. That's a frozen meat from my freezer. So we can get that down to 0. So right now you could do the math for the calories on that. And that's energy. This is going to be resistance. Now I'm going to pull my sensor off right here to show you what I used. This is, again, a knock sensor. If I disconnect the sensor, I get no resistance. I'm going to plug the sensor back in. This is the knock sensor, so if I was to take this and I kind of knock it, see how I'm knocking it? It's messing it all up, but when I let it go, it goes back to normal. Knocking. So I measured kinetic resistance. I don't know how the formulas are going to go for making it move and how that plays into what formula I need to make that propulsion. I know the Maycore 1 formula is that. I would use this for my measurements on the Maycore 1 formula. Wherever that is, I can't find it right now. I have to dig out a wallet or go through a whole bunch of stuff, but there you go. I used a knock sensor to measure kinetic resistance. Awesome.